And this one's take a look at the fundamentals of sigma notation. So this symbol, this is the Greek letter sigma, and what it represents in terms of a mathematical operation is this. Okay, it represents adding up or summing. Let's look at concrete examples. So sigma, for example, here, and on the bottom, what often is put there is the starting value of a variable, like I equals 1. And on the top, you might put the stopping value of a variable, like I equals 3. And then here you put the expression that you want to add up. So let's carry this out as an example. Here I might say 1 plus 2 plus 3. Now, this value in this position, that's just the starting value of the variable, and this value is the stopping value of the variable right here. And then the implication is that because you're adding up, that it goes one by one by one. So it goes like from 1 up to 2 up to 3. Then you can just add that up. So 1 and 2 is 3, 3 plus 3 is 6. Another example. Often when you write this, you will not see, you will see it this way. You will see I equals, for example, 1, but up top you might have just 4. You will not see like I equals 4 as the stopping value, but that's what it's implied. That the starting value is on the bottom, the stopping value is on the top. And let's look at this expression right here. So I, for example, plus 1. How do we carry this out? Again, wherever you see I, you replace it with its values. When it goes from 1 to 4, it goes 1, 2, 3, 4. So in this case, to make a small note, the values of I implied by this symbol are the following. I goes 1, 2, 3, 4. Keep that in mind. I wrote that up there for that reason. And then you just replace. So it's going to be 1 plus 1 plus, and I'm going to put this within a parenthesis to indicate it's a unit. And it's going to be the next value of I, which is 2. So 2 plus 1. And the next value of I, which will be here 3 plus 1. And the last value of I, which will be 4 plus 1. So here, this value in this position, this is the starting value of I. And that 4 in that position, that is present precisely because that is the stopping value of I. And then you have the intermediate values 2 and 3. So that's a value of I, that's a value of I, that's a value of I, all the way from beginning to end. So let's work this out over here. So 1 and 1 for the first one is 2, 2 and 1 is 3, 3 and 1 is 4, 4 and 1 is 5, and then you just add that up. So 2 and 3, 5, and 4, 9, 9 and 5 is 14, and that is the value of the sum, 14. Another example, take a look. Sometimes it might look like this. So the sigma here, and then you have 2i. Say I goes from 1 to 3 this time, and you apply the same logic, so it's 2. You plug in the first value of I from the bottom, which is 1, and then 2. You plug in the next value of I. Again, in this case, I goes from 1 to 3, so the possible values of I, let's make that note, that's important. It's 1, 2, 3, right? The starting value, stopping value, intermediate value, like 2. So back here I will have 2 times 1 plus 2 times 2 plus 2 times 3. And when you work this out, this is 2 plus 4 plus 6. So you work that out. That's going to give you here 12. And that is the sum. Again, this value right here, this is the starting value. And that there is the end value. Let's do one more of these. It also turns out that when you have a constant, like for example 2 in this position, and you're iterating or going over the values of I from, say, I equals 1 to I equals 3, you can do it this way. You can pull the 2 outside, and you can copy the sigma symbol, and it looks like this. Take a look. So I pulled the 2 out of the sigma symbol, and then I work on the sum. So it's going to be 2, and then you work out the value of the sum, for example, within brackets or parentheses. In this case, I will be 1 plus 2 plus 3. Again, that there is the start value, right? And that there is the stop value. And then you just work that out. So it's 2, 1 and 2 within the brackets there. That is what I'm doing. It's 3, 3 plus 3 is 6. Then you end up with a value of 12. And notice that this value of 12 is the same. Look back on the previous pane right here. This is also equal to 12. It's the same value. The only difference is when you have a constant like 2 in the sigma symbol, you can pull it out. Another example, sometimes what you can do is add up a constant. Take a look. Like you might have 1 in this position and say I goes from 1 to 5. How do you evaluate this? Well, notice that the expression you're adding up doesn't actually involve the variable I. It's just a constant 1. So to do it is you put the 1 down and you put it 1 more time. and you put it one more time, and you put it one more time, and you put it one more time. Why is that so? Think about it. How many of these do you have here? Well, you have precisely 5 of them because I goes from 1 to 5. So you're going to add up 5 ones, which naturally means at the end you're going to have 5 as the value of the sum. 1 and 1 and 1 and 1 and 1 is 5. And that's it for this one. Thanks so much for watching. Please leave a like. I'll see you in the video.